Hello students, today we're going to talk about literal equations. Literal equations are equations with multiple variables. Equations with multiple variables. And so let's look at these examples. Solve each of the equations below for x. So in each equation, we're solving for x. So for the first one, we have 2x minus 5 equals 13. And we know what to do with this. We want to isolate that variable by first adding the 5 to both sides of the equal sign. And then we're going to check that we've done the right thing. Negative 5 plus 5 is 0. That's what we want. We want just that 2x by itself. And 13 plus 5 is 18. And then we have 2x, which means 2 times x. The inverse operation of multiplication is division. So when we divide both sides by 2, we get x equals 9. And that's something we've done a lot of, and we should be fairly comfortable with that. The second equation says a times x minus b equals c. So we're going to treat it the same way. We're solving for x. So the first thing we need to do is add the b to both sides. Negative b plus b makes 0, which is what we want. We're just left with ax equals. You can either do c plus b or b plus c. Either way is fine. I'm going to do b plus c, just keep it alphabetical. Then we have a times x, and we know the inverse operation of multiplication is division. Okay, and remember, we're trying to get the x by itself, so we're going to divide by a on both sides. A divided by a, that just makes a big O 1, and 1 times x is just x. So we've got the x by itself. And over here, we're going to leave that as b plus c over a. There's nothing else we can do with that problem. And this, what we did right here, you have just worked with your first literal equation. It's an equation with multiple variables. Here your variables were a, b, c, and x. So let's do a quick write and identify the similarities and differences between the two equations. So one similarity that I saw, both use inverse, or we could call those opposite operations to isolate. Both use inverse or opposite operations to isolate that variable. But a difference, so there's my similarity, a difference that I noticed between the two is the literal equation doesn't simplify nicely. Due to multiple variables. That literal equation doesn't simplify nicely due to multiple variables. So I didn't get an answer like x equals 5, right? I just had to rearrange the equation. So let's do some practice with this, shall we? Let's take a look at number 1. A equals L times W. Now, we probably know that's area equals length times width, but even if we didn't know that, it just wants us to solve for W. That means we're trying to get the W isolated to one side by itself. So right now I have L times W. Well, we know the inverse or opposite operation of multiplication is division. So I'm going to multiply both sides by L. And guys, I use a nice little cursive L when I do this. Otherwise, my L's and my 1's look similar. You don't have to do that, but that's what I like to do. And I'm going to put my variable right here on the left-hand side of the equation. So width will be A divided by L. I isolated for that width. Number 2 is very similar. A equals BH. Solve for H. So I'm trying to solve for this H right here. Well, I have B times H. So all I have to do is divide both sides by B. Those B's cancel. I'm going to put my variable on the left side, and then I'll put A over B on the right side. And I have solved for H. I got the H all by itself on one side. And I forgot to box this one. Let me fix that. All right, number 3, solve for T. Solve for T. This is distance equals rate times time. And we need to solve for T. Well, I have RT, so the inverse of multiplication is division. So D over R equals T. Or the better way is to put that variable on the left. T equals D over R. Number 4, I equals PRT, and it wants us to solve for T. Okay, so again, P times R times T. The inverse of all of that would be division. So I'm going to divide the PR at the same time. So that PR will cancel. I have I over PR equals T. And that's interest, principal, rate, and time, which again, you don't need to know that to be able to solve these. So I'm going to put my variable on the left. And we're done. Number 5 is very much like number 4, so I want to skip it for now. Let's go take a look at number 6. Number 6 is interesting. Number 6 says solve for R. Solve for R. Let me see if I can make this a little bit smaller for you guys. We want to solve for R. Okay? Not R squared, but just R. So my first step here is I have pi R squared, so I'm going to divide both sides by pi. And so that gives me, and I'm going to rewrite this so my R squared is on the left. A over pi. But I'm not done. It didn't say solve for R squared, it said solve for R. And so, when I have R squared, to undo squaring something, I would take the square root, right? For example, if I have 2 squared, that's 4. Okay? Well, to undo that, I would take the square root of 4, which is 2, also could be negative 2, right? So we're going to do the same thing down here with this R. I'm going to take the square root of each side. So I have R equals the square root of A over pi. Remember, square roots can be plus or minus, because when we square a negative, we get a positive. So I have to put the plus or minus in front. Let's do one more from this page together. We box that one. Let's go to number 8. Number 8 says solve for M. Solve for M. And I don't know if you noticed, but a strategy I've used is I am highlighting what I'm solving for. I think it just makes things a little easier as we're moving variables across the equation. All right, so m divided by v, the inverse of division, is multiplication. So I'm going to multiply both sides times v. And we know that the numerator of one fraction and the denominator of the other fraction cancels, and I'm just left with m equals d times v is written as dv. But I like my variable on the left side, so m equals dv. I would like to point out to you that if you have a capital letter, we need to keep that as a capital letter. And if you have a lowercase letter, we need to keep that as a lowercase letter. See, all these are lowercase. That's important. All right, I'll see you on the next video.